In this lesson, we look at these angles that get formed when two parallel lines are cut by what's called a transversal. So it tells us that lines M and N are parallel. So they're right here. Now we know they're parallel because it says it is, also because they give us these lines, which are the symbol for parallel, two vertical lines. Okay, as you know, parallel lines never touch, they never intersect. These are not right angles, but just as a vocabulary word, when lines create right angles, when lines intersect and form right angles, they're called perpendicular. Please check your spelling. Now the third line that they show us in the picture is line Y, because they've already told us about M and line Y is what we call a transversal. You might remember from your roots and prefixes that transverse means to cross, so it's crossing the two parallel lines. We don't use the word crossing in math, we use the word intersecting. When parallel lines are cut by a transversal, we have some special angle pairs formed, and these angle pairs are made up of congruent angles. Now, hopefully you remember what congruent means, but back in 7th grade or 6th grade, you learned that congruent means equal measure. So if you know the measurement of one angle, and you know that it's congruent to another angle, then you can find that measurement as well. And I'm not sure if you were taught the symbol for congruent, hopefully you were, but the symbol for congruent is an equal sign with a little squiggle on top. So when two parallel lines are cut by a transversal, that's how we would describe this picture over here. Here's two parallel lines and they're being cut by this transversal. We have these super cool angle pairs that are formed. So what I'm going to do is I'm going to give you the vocabulary word for the relationship. I'm going to give you the definition of that vocabulary word, and then I'm going to show you which angle pairs that word refers to. So first angle relationship, you might remember this from 7th grade, is vertical angles. And vertical angles are angles that are kind of like across from each other, but at the same intersection. So the angles that would fit this description would be angles 1 and 4. So you see they're like across from each other at this same intersection. So that's our first angle pair. Another angle pair is going to be at that same intersection, angles 2 and 3. And then when we go down to the other intersection, we have angles 5 and 8, and angles 6 and 7. So we have 4 angle pairs that we would call vertical angles. And the cool thing about this is if we know the measurement, let's say, of angle 1, then we can figure out the measurement of angle 4 because these special pairs are congruent, and congruent means equal measure. So if I know the measurement of angle 7, I can use my knowledge of vertical angles to find the measure of angle 6 because it's going to be the same measurement. Corresponding angles are angles that are in the same spot but different intersections. The angles that would represent corresponding angles would be like angles 1 and 5. So you see, if I look at the top intersection and the bottom intersection, you can see that angles 1 and 5 are both in the top left of their intersections. So that would be my first one, angles 1 and 5. Another relationship that's corresponding would be angles 2 and 6 because those are both in the top right. Hopefully you're recognizing these now. Then we would have angles 3 and 7 because those are both in the bottom left. And then the last one would be angles 4 and 8 because they're both in the bottom right. So if you know angle 1, you know angle 5 because it's corresponding. If you know angle 8, then you know angle 4 because they're corresponding. And corresponding angles are congruent. The next one that we've got is alternate interior angles. So I'm going to scroll up and down so I can kind of get the definition and the angle pairs and then get to the picture. Alternate interior angles have kind of a long definition only because it's a little complicated to explain where they are. But once you see them, you'll understand what all the parts mean. So the first thing is that they're inside the parallel lines. The next thing is that they are at different intersections. And the third part is that they're on different sides of the transversal. All right, so let me show you where those angles are. So if you don't have the definition down yet, pause the video because I'm going to scroll up to the picture. So what I'm going to do is draw like a rectangle around the parallel lines to represent inside the parallel lines. So here's my rectangle. So these two angle pairs, or these angle pairs, to be alternate interior, they have to be inside the parallel lines, so they're inside this rectangle that I just drew. They have to be on at different intersections, so here's one intersection, here's the other intersection. And they also have to be on different sides of the transversal. So if one angle is on the left, its partner has to be on the right. And there are only two pairs that fit this criteria. The first pair is angle 3 and 6, and the other pair is angle 4 and angle 5. All right, now here's what's kind of a little good. The only difference between alternate interior angles and alternate exterior angles is that instead of being inside the parallel lines, alternate exterior angles are outside the parallel lines. We're going to copy this exact definition over, but instead of inside, we're going to turn it into outside. And the reason that we do that is because interior means inside, so exterior means outside. So we're just going to change the word inside to outside and then copy everything else. All right, so if you don't have the definition, I'm going to pause for a second so you can copy it down, and then I'm going to scroll up to the picture. All right, so let's look at outside the parallel lines. So now we're going to look at, I'll use red in my picture, and we're going to look outside the parallel lines. So we're looking here. Okay, so our two angles, angle pairs, are angles 1 and 8 because they're at different intersections. They're on opposite sides of the transversal, and they're outside the parallel lines. And the other pair is angles 2 and 7. I know I've said it a bunch of times, but we're going to fill in a box about it right now. Any of these pairs that I've just mentioned are congruent. So if someone says, I know the measurement of angle 3, you can find the measurement of angle 6, you can find the measurement of angle 7. If someone says, I know the measurement of angle 2, you can find the measurement of angle 6, you can find the measurement of angle 7, because it all partners with somebody. If it's not a partner up above, then the angles are supplementary. And just to refresh your memory, supplementary means that it adds to 180. All right, let's put this into practice. Remember, I told you that all of these special angle pairs are congruent. So if you know one, then you know another. Let's look at this. Let's start off pretty simple. Use the figure to find the measures of angle 1 and angle 2. So let's look at the picture, and they give us this one angle 110, and they want us to jump all the way over here to angle 1 and 2. And you say to yourself, how am I supposed to know what these measurements are? But since these lines are parallel, and they give you those little markings right here, these triangle things are marking that they're parallel, 110 and 1 have a special relationship. I'd like you to pause the video and see if you can name that relationship. If you said corresponding, then you've done it correctly. Angle 110 and 1 are corresponding, oops, too many eyes, corresponding angles. So if you know angle 110, which you do because they tell you it's 110, then angle 1 must also be 110 since they have the corresponding relationship. So angle 1 is 110 degrees, and if angle 1 is 110, then these two angles together, angles 1 and 2, make 180 degrees. So that means that angle 2 must be 70 degrees because 180 minus 110 is 70. Done. Number 2, use the figure to find the measure of each angle. So same idea. Let's check it out. 63 they give us. And what relationship do 63 and 1 have in common? If you said corresponding, then you're correct again. These are also corresponding, the 63 and the 1, because they're in the same intersection, or same position in different intersections. So the measure of angle 1 must also be 63 degrees. If angle 1 is 63 degrees, then angle 2 must be 180 minus 63 degrees, which is 117. Done. So we're going to start off in number 3. We have to use the figure to find all of the angles. So we're going to have 7 answers in total. Whoa. All right, so I want you to have your chart handy. I'm going to ask you to pause a couple times. I want you to go through the chart, and the first thing that we're going to look for is corresponding. So find me the angle that corresponds with the 75. Pause the video and find it. The angle that you're looking for is angle 6. So if angle 6 is corresponding, then we know that it also equals 75. So I wrote angle 6 equals 75, and then I wrote corresponding to reference how I knew that. And I also put an X over angle 6, so I know I don't need to find it anymore. Now I want to go through the chart, and I want you to find me an alternate interior angle with 75. Pause the video and find it. The angle that you're looking for is angle 4. Angle 4 is also 75, and I'll write down that it's alternate interior. And let me cross out angle 4 because I found it. Now the next one on the chart is alternate exterior, and I don't want to find alternate exterior because the 75 isn't an exterior angle. It's inside these parallel lines. If you make the rectangle, then you can see that the 75 is inside the rectangle. So I can't find an alternate exterior partner. Typically, you're either one or the other. You can't be interior and exterior. So my only other one left from the list is vertical. Pause the video now and find me a vertical angle to the 75. Angle 1 is vertical, and so that's 75 degrees. I'm crossing off angle 1, and I also wrote that it's vertical. Now, hopefully, you realize that we used all of the things from our list, so all the other ones have to be supplementary. So 180 minus 75 is 105, so that means all the other angles, angles 2, 3, 5, and 7, are 105. All right, so I found all of them, and I just needed to use that chart. All right, last one, number 4. The photo shows a portion of an airport. Describe the relationship between each pair of angles. So hopefully you have your chart handy. So look at your chart and see if you can figure out which relationship describes angles 3 and 6. If you said alternate exterior, you're correct. All right, try it with angles 4 and 8. All right, if you picked corresponding, you are correct again. If you have any questions, write them down and ask me when you come to class.